Every time you start your car, something extraordinary happens. Beneath the hood, a carefully crafted machine awakens, a symphony of metal, motion, and fire. But have you ever stopped to wonder how this miracle of engineering comes to life? From raw chunks of aluminum to a roaring powerhouse capable of propelling a car at highway speeds. The creation of a car engine is one of modern industry's most complex and fascinating processes. In this video, we'll journey deep inside the factories where precision meets power to see exactly how an engine is born, step by step. This is the story of transformation. This is how a car engine is made. Every component you'll see, from molten metal to moving pistons, represents decades of engineering evolution. Behind every engine lies the combined effort of thousands of workers, designers, and machines, all working with incredible precision. From the intense heat of the foundry to the quiet hum of robotic arms, we'll uncover the secrets, science, and craftsmanship that turn simple elements into the driving force of modern life. Every engine story begins with a single element: metal. In a vast foundry filled with heat and light, aluminum ingots are stacked and prepared for their transformation. These solid blocks of metal are the raw bones of what will soon become a heart of steel and fire. Traditionally, engines were made of cast iron, durable but heavy. As vehicles evolved, so did materials. Today, lightweight aluminum alloys have become the standard, reducing weight while maintaining strength and efficiency. The process begins with melting. Workers carefully load aluminum ingots into an elevator bucket positioned above a powerful gas-fired furnace called a jet melter. Inside, temperatures soar above 800 degrees Celsius. Within minutes, the shiny silver metal softens, collapses, and turns into a glowing liquid mirror of molten aluminum. Once fully melted, the aluminum is collected in a massive crucible, a container designed to handle this blistering heat. The molten metal will soon give shape to one of the most precise components in any machine, the engine block. While the aluminum is melting, another crucial process takes place: the creation of the sand molds that will form the shape of the engine block. A special high-temperature sand, often made from zircon, is prepared and mixed with resin and a chemical hardener. This blend must withstand the molten metal's heat, but still break away easily once the casting is complete. In a separate part of the factory, a machine blows this sand mixture into an iron master mold, a template that defines the engine's intricate geometry. A catalytic gas is then injected, triggering the hardener to activate. Within seconds, the sand solidifies into a firm, heat-resistant shell. Each mold is inspected by skilled technicians and robotic scanners. These robots measure every angle, ensuring each cavity and surface matches the digital design with millimeter precision. Once approved, the sand mold halves are carefully locked together, ready to receive the molten metal that will give them purpose. Now, the most dramatic moment of all: casting. The molten aluminum is transferred from the furnace to the casting station. It must stay pure, free from contaminants and oxidation. For that reason, it is poured from the bottom of the mold, not the top. This bottom fill method prevents the molten metal from splashing and mixing with air, which could form oxide impurities. As the aluminum flows into the sand mold, it races through a network of gates and channels, filling every void and corner with molten light. In just a few moments, the glowing metal takes the form of a solid engine block. Once the metal cools and hardens, the mold is unlocked and removed. What emerges is a rough but recognizable block, the foundation of an engine. Workers carefully lift the fresh casting from its mold. The air is filled with the hiss of cooling metal and the crackle of sand breaking free. The cast block still carries remnants of its sandy shell, but beneath lies a single, continuous piece of aluminum, precisely shaped and incredibly strong. The next stage is cleaning. Every trace of sand is blasted away, leaving behind a clean metallic surface that gleams under the factory lights. High-pressure air and abrasive particles scour the block, reaching every corner and crevice to reveal the pure aluminum beneath. Technicians examine each block by eye and by instrument. Powerful lights and advanced imaging tools expose even the tiniest imperfections that the human eye might miss. Any visible flaw, crack, or cavity could spell disaster later, so quality control is uncompromising. Blocks that pass this first inspection move forward. Those that don't are melted down and recycled, rejoining the cycle of creation to start anew. At this point, the raw engine block is complete, solid, symmetrical, and full of potential. Yet what we see now is only the skeleton, the foundation waiting for life to be breathed into it. Soon, this inert block of metal will become a living machine, brought to motion through precision, combustion, and the brilliance of human engineering. The cast block is sent to a machining center, where automated equipment turns the rough casting into a perfectly measured mechanical component. First, the engine block is 3D scanned. A digital model of the physical block is compared against the computer-aided design, ensuring every measurement is within microscopic tolerance. If any defect is detected, the part is flagged long before it reaches assembly. Next, precision cutting tools begin their work. Computer-controlled machines bore out the cylinder holes, the chambers where pistons will move up and down. The tools create a distinctive crosshatch pattern inside the cylinder walls, a texture that helps oil cling to the surface. This thin film of oil reduces friction and ensures smooth motion when the engine runs. Machining also includes drilling channels for coolant and oil flow, milling flat surfaces for gaskets, and carving out bolt holes that will later hold the entire engine together. Every pass of the tool is measured, recorded, and verified. Once machining is complete, each block undergoes another round of inspection using cameras and lasers. The surface finish, alignment, and internal geometry must be flawless. These checks guarantee that every engine will perform identically, no matter where in the world it's built. While engine blocks are being machined, other essential parts are being born. The pistons, those rapidly moving cylinders that compress air and fuel, are also made of aluminum, prized for its combination of lightness and heat resistance. Molten aluminum is poured into piston molds and cooled, then precisely machined to achieve perfect balance and size. Each piston connects to a steel connecting rod, which in turn links to the crankshaft, the part that converts the piston's up and down motion into rotational energy. The crankshaft begins life as a solid piece of forged steel. Under massive hydraulic presses, it is squeezed, twisted, and hammered into shape. Once forged, it undergoes extensive machining and polishing. Every surface must be perfectly smooth. Even the smallest imperfection could cause vibration or wear at thousands of revolutions per minute. When all the components are ready, they come together on the assembly line. The engine block, now smooth and gleaming, is fitted with bearings, oil seals, and the crankshaft. Workers carefully lower the crankshaft into position, securing it with precision-torqued bolts. The connecting rods are attached next, followed by pistons sliding smoothly into the cylinder bores. Each movement is deliberate. Every nut and bolt is tightened to a specific torque specification. Robots and technicians work side by side, combining the accuracy of automation with the careful eye of human experience. As the assembly line moves, the camshaft, timing components, and cylinder head are added. The head contains the valves and passages that control air and fuel flow. It's here that combustion, the heart of the engine's power, will take place. Fuel injectors, sensors, and wiring harnesses connect the mechanical with the electronic. Modern engines are no longer just metal, they're computers on wheels. Before an engine can leave the factory, it must prove itself. Each unit is fitted with temporary fuel and cooling lines, then taken to a sealed testing chamber. Here, the engine is fired up for the very first time. As it roars to life, technicians monitor every vibration, every sound, every pulse. Computers record temperature, oil pressure, fuel efficiency, and emissions in real time. If it meets every target, it passes. If not, it's analyzed, corrected, and retested until perfection is achieved. Once the test run is complete, all bolts are retightened to final torque, and the engine receives its serial number, its unique mechanical fingerprint. From here, the finished engine is carefully packaged and shipped to the vehicle assembly plant, where it will be fitted into its chassis, the final step before it comes to life on the open road. Technicians prepare it for installation, connecting fuel lines, wiring systems, and control modules that will allow it to communicate seamlessly with the rest of the vehicle. What began as a pile of raw aluminum and steel has now become a marvel of human engineering, a machine capable of producing thousands of controlled explosions every minute, yet refined enough to deliver a smooth, quiet, and efficient drive. Each component, from the smallest bolt to the largest crankshaft, plays a vital role in transforming chemical energy into motion. Every revolution of an engine is a tribute to human creativity and precision, a harmony of science, design, and craftsmanship working together in perfect rhythm. This is the journey of an engine, from molten metal to mechanical masterpiece, from the heart of a factory to the heartbeat of every car on the road. If you enjoyed discovering how something as complex as an engine comes to life, make sure to leave a like. It really helps us keep making more videos like this. Tell us in the comments which part of the process amazed you the most: the blazing foundry, the precision machining, or the final moment when the engine roars to life. And if you want to keep exploring the hidden world of engineering and manufacturing, subscribe and turn on notifications, because we have many more fascinating stories coming your way. Thanks for watching.